Hello, this is a video for CS 471, 571 operating systems, looking at a few of the homework assignments. So let's take a look at what those homework assignments are. All right, I am looking at the homework 1 homework assignments. There are 3 of those. You should first, if you haven't already, pause the video and read what this says. Okay, now I am going to show you my program. And so that you can test it out, I'll go ahead and put my program out here. And if I need to make any corrections to my program based on mistakes that you might find, I will update that here. All right, so let's look at the first one here. So this, for this one, we're copying files. So this is the program that copies files. And what I wanted you to do was add some extra parameters. And this gives the usage statement. So I'm going to copy this file here, and this gives a buffer size to use in the call to read and write. So it's going to read or write that many bytes at a time. And then this is either O_sync or not. So I would run it like this. Let's see. I'm going to copy over the files that I was using as well. Let's say 1 megabyte here. So this 1 megabyte.dump is a 1 megabyte file. So I'm going to copy this 1 megabyte to be called something.2, and then I have to give it a buffer size. Let's say 1, and sync or no, I'll just say no. All right, so that took some amount of time, and I would like to time that. All right, that took 0.064 seconds in my actual code. It took 1.094 seconds for the operating system to do that, and then the actual elapsed time is this 1.159. All right, if I make it a bigger chunk, then what do you think should happen? Should it be faster or slower? Much faster. If we look at this version here, that's going to be 1 million different reads and writes. This is going to be 1,000 different reads and writes. And because of the way disks work, this is faster. We could go up to all the way up to 1 million. Okay, and then the last thing here can be O_sync. And we could go up to a block size of 1,000 with O_sync as well. All right, so what I'm asking you to do is for files that are 1 kilobyte, 1 megabyte, and 10 megabytes, run your program after you made it do this. So run your program with 1, 1,000, and a megabyte, and with sync or no sync. And I'll put my homework1 underscore homework1 results.txt. All right, so for my 1 megabyte file, I would have O_sync, not O_sync, and I'd have here block size. All right, you could put this in a spreadsheet, or just a text file like this is fine. So this is 1, 1,000, 1 million. All right, and then put in here, I'm saying to put the real time, so the elapsed time. Let's go ahead and do that again. So copy like this. I'm going to do by 1 megabyte file and copy it to be over here. And then I'm going to do 1 and sync. And I need to do time as well. All right, so the value that I'm going to do is this 1.162. All right, and then you fill this out with the rest of the running times, and then you want to think about, does it make sense, the running times that you're getting? All right, that's the first problem. Good luck. Make sure to name your, so make a homework directory, capital HW, name your homework file the same exact as mine so that when I go to look for it, I'll find it. All right, second problem is this one. I'll copy my program in here as well. Not that. Copy in the actual program. All right, so let's run this, and the way this runs is you give it a file name or it reads from standard input. Let's give it a file name. I think let's see, I have something here, test1, so I'll do test1.txt. All right, if I look at test1, that just has numbers 1 up to 23, 1 per line. And after you read this, so pause it to read it, what it's supposed to do is print the first 10 lines, print the last 10 lines, then some stars, and then it's going to print the total number of lines, the total number of words, and the total number of bytes. And these three numbers should give you the same as what word count would give you. Okay, so I'm calculating the number of lines and words in the same way as word count. So I'll say hint for counts, do the same as WC, WC counts /n's for the number of lines. We'll leave it like that for now. Okay, so this is one test file where you can see what happens. There's two other test files here that are worth looking at. So there's a test file that's less than 10 lines, and if it's less than 10 lines, you just print the first, right? You just print the whole file because it's less than 10 lines. And here's a test file that is in between 10 and 15. So you should print the first 10, then the ... and then the last lines. Like this. Okay, so that's defined to be the correct output. I put a hint here. You may want to use strtoc. You may want to use getLine. GetLine will get a line of text. No matter how long the line is, it'll allocate the amount of space needed. strtoc is used for splitting a line up into words. Okay. Last is the doing some version of run. So read this. Okay, now I'm going to copy mine in. Okay, so the way this program was working was it's going to, this was the example that uses fork and exec. It's sort of like a simple shell, so I could run ls. The first bullet point here says if you give a command line argument, use it as the path. So if I do run like this and I say /bin, I'm going to type ls. I want to put /bin/ls as the name of the program to run. Alright, so that's the first thing. I just put that on as the first command line argument. Second bullet point here is whatever they type. If I do -l like this, the way the code was that I gave you from class, it would consider this whole thing as the name of the program to run. And so that's, if you run that one from class, you should try that and see. I believe it'll give you, it won't work. It'll give you an error that says it's not a valid program. So it would be just like doing, some not valid program. So what the second bullet point says is to actually parse. You have this as a file name that you're going to load as the program, and then the rest is supposed to be the arguments. If you look at that program, the exec VE, this is supposed to be the program itself, and this is supposed to be an array, so an array of pointers to arguments. So if I wanted, sorry, this one here. So if I wanted the arguments to be /run 471, or let's say if I wanted the arguments to be /bin/ls-l-hello or something like that, then this new argv would be /bin/ls-l-hello and with a null pointer at the end. Alright, so you could hard code that in, and if you run it, then it should run this command. What the second bullet point is asking you to do is this command that comes from reading from the user, parse it. So it's going to be something like this. From the first part, you're going to have the path. Now I want you to parse this, and I'm suggesting you use strtoc. Okay, that's this bullet point. The last bullet point is that if there's more than one argument here, then try each one in order. So my program, first it looked for /hello, and it tried to see if /hello/ls exists. It didn't, so then it moved on to use the next one, and I did use the stat function. Okay. All right, so that is this one, and you have my code there that you can test out. Good luck and have fun.